Hello, my name is Angela Rastani. I'm the Vice President of Marketing at Hedvig. Thank you so much for joining us for today's webinar. The topic is how to deliver cloud era storage more efficiently than Ceph. To be considerate of your time, we will keep the presentation pretty close to 30 minutes with a few minutes for questions. Please feel free to post any questions you may have through the questions area of the control panel. We will answer as many questions as time permits at the end of the presentation. Now I'm very pleased to introduce Christopher Hill, Hedvig's Vice President of Field Engineering. He's a software-defined storage guru, and by the way, he's a terrific musician. Maybe next time for our webinar, we'll get him to play a couple songs for us, but no pressure, Christopher. With that, Christopher, please take it away.
Thank you. And just as a quick gut check, can you hear me well, Angela?
You sound great.
Perfect. I promise I won't play guitar on this session, but we'll have a wrap up. We'll have an after party later where we can pull that together. So thank you all for joining. I have a little bit of a whimsical title today. That question, what would Google do? I grew up in the Deep South, and I was often chastised aggressively by my mom, and she would challenge me to ask the question, what would Jesus do? As if there were some way, that I could go do that. And it was a challenge when I was 12 and 13, and a bigger challenge when I was 21. But today, I think it's something that we all look at a little bit closely as we think about what some of the newer, more modern, really efficient and successful companies are doing out there. And it's not just Google, it's the Facebooks and the Amazons of the world. And we should, at our heart, really be asking ourselves whether we can do some of those same things as well, and whether we can engage in that kind of efficiency and that kind of success. So we'll talk a little bit today about that challenge and that effort that as closely as possible we want to mirror the guys around us who are being successful and try to achieve some of what they're achieving where it's relevant. So at the beginning, or at the start, we can look at a pretty simple premise, which I think everyone can agree is true, that in a time of major transformation of how we're tackling technical issues today, data is really at the heart of it. And that's happening because there are billions of devices, millions of users that we're interacting with and working with, and we're capturing more and more data about each of those elements. And it seems that every facet of what we're doing is coming to be captured today and needs a location. No one's wrestling with that more than the Apples, the Googles, the Facebooks, the Amazons of the world. The trick, though, especially in a storage context, and Hedvig obviously is a storage company, software-defined storage, is how to provide the data infrastructure for those elements and how to do it for an ever-broadening set of applications in the digital enterprise. And it's something that we've done historically, dealing with these large data sets. Some of the enterprises out there that are not among the digital giants have still been wrestling with this for the past decade or more. Even smaller enterprises are beginning to wrestle with it aggressively today. The question is, how do we go do that? Traditionally, we've used storage arrays, extensive silos, specific applications or specific data structures for backup, for archive, for production, broad range of use cases and needs, often each with their own silo from a storage perspective or an infrastructure perspective. And the key element here, when we look at the Googles and the Amazons and the Facebooks of the world, that's not how they do it. Frankly, they've engaged over the last decade and a bit more in developing a set of structures that allows them to handle things better. And we're beginning to see it, right? If we look, this is a great quote from 2018 about fourth quarter 2017 results, where despite tremendous growth in the storage market that we still see today, the dedicated array section grew at less than 10%. And that's evolved even further. Those traditional arrays, storage is flat from a revenue growth perspective because everyone is pushing in the greatest way possible towards software defined, whether that means things like Nutanix and SimpliVity or Scale.io or Hedvig. There's ultimately a significant rejection of the standard array, and that's not new. I think it's new for for us in some ways as enterprises, especially in the small and medium-sized businesses. But I think back to about 10 years ago, when I was at Pillar Data Systems, a no longer existent software storage startup. We were selling very strong, powerful storage arrays, and I remember sitting in Silicon Valley at our headquarters in San Jose and sitting across the desk from two guys in really scruffy hoodies, half shaven. I was there in my sort of New York City button down and blazer. And I remember explaining them for a good 45 minutes what was so great about the Pillar Data Systems array and how effective it was going to be for them and what a great job it was going to do. And these are the two founders of YouTube, by the way, sitting across the desk from me at a time when it didn't matter that much that that's who they were. We finished our presentation. They thanked us. They huddled in the corner for about 5 minutes, came back to the table and said, "It sounds like you've built a really good array. Sounds like it's really great for a lot of things, but I think for our use case, we can go build it better. So I think we're just going to build it ourselves." And 10 years ago, that sounded like madness. But looking back now in retrospect, the guys were right. And what we've seen over the last 10 years is that desire to custom craft and build these software-defined storage frameworks has taken off and absolutely dominated in the large enterprise space of these cloud giants. Today, it's just beginning to surface as an absolute need for what I'll call standard enterprises, the retailers of the world, the manufacturers, the banks of the world. And we're now asking ourselves that question. This is something that the big cloud giants have been successful in. How can we do that too? And arrays are not getting it done. We know that that's not the answer, but we're all beginning to build to a set of requirements that are felt first and foremost in these cloud giants, but which we all wrestle with. How do we increase our agility and accelerate our time to market? How do we respond aggressively to a set of business units that have grown accustomed to the ability to go grab virtual machines and containers from Amazon in the blink of an eye, to go grab storage from GCP in the blink of an eye? How do we do that in a way that's policy-based and secure, that offers encryption and dedupe and all of these enterprise features? How do we automate that so that we're seeing the same kind of efficiency that we're getting in Google and Amazon, where they're managing thousands and thousands of machines per individual? And most importantly, in some ways, how do we achieve the level of uptime and availability that these players are using? We've always wanted uptime. Everyone's asked about 5 nines or 6 nines or whatever the target was. But this is being handled in a way today which is, has shifted what's allowable or what's acceptable. My Amazon shopping cart is never down. My Facebook Messenger is never down. I can always get to Gmail. There's an assumption of absolute 24/7 always on permanence that's been delivered. And it's in the context, frankly, of a scenario where it's also very cost efficient. Google makes money selling clicks per at fractions of a cent for ads. It's critical that all of the benefits that they're getting and all of the needs that they're meeting are also happening at a TCO model or a cost model that's far lower than traditional arrays allow. And if we did nothing else but this and still maintain that sort of traditional model, it would be challenging enough. And there are a number of tool sets to go do that without resorting to arrays. But it moves even beyond that. And when we look at what Google has done, when we look at what Facebook and Amazon have done, and how they've come to achieve some of these needs, they've done it by adopting an approach where individual disk drives have been disposable for a long time, and that continues to be true. They've moved to a position where the compute hardware, the storage hardware itself, has become disposable and is managed more like cattle than pets. That is now true. But it's gone beyond that, where they've adopted an operational approach that distributes data and incorporates data not at the single data center, but across town in different data centers, across continents, and occasionally across the world. And that embrace of the global virtual data center is what really sets apart these cloud giants, the cloud era successes, from even the mainstream enterprises that have been wrestling with the same data growth and the same challenges over the past decade or so. And that's the real question, is how do we achieve that? How do we move beyond this real limiting factor of the single data center? How do we move beyond that traditional array and go satisfy some of these needs? Standard arrays don't get it done. We know that, there's a reason for that. The hardware is too expensive. It's built from a silo-based mindset where we've got all great products, by the way, Data Domain for backup, and we've got Pure for really fast local database access, and we've got Nutanix for VDI, but without the ability to go drive down cost through true standardization. And we haven't seen the kind of decay in capital expense and operational expense in the standard enterprises that the cloud giants are getting to. We've got challenges with traditional arrays being inflexible. Again, that silo-based approach that I'm buying a piece of gear for a particular problem. The demand for really rigid hardware, which has storage companies, whether it's a NetApp or an EMC or a Hitachi, out there bending and painting sheet metal to go deliver an array, when really the internals could easily be sourced on a more commodity-based approach. Difficult to automate and truly software defined, difficult to really move away from manual provisioning efforts and reduce staff. And most importantly, with these traditional arrays, the inability to really get to fundamental scale, and not thinking about hundreds of terabytes, which we once would have thought was large, but dozens of petabytes and even hundreds of petabytes. So that lack of real agility for scale out capability limits the traditional arrays' fundamental ability to go do these things. When I look at the options, then what does a standard enterprise do, and what have we been trying to do over the past decade or so to meet some of these challenges? And one pathway for that is Ceph, which is a fantastic product in its regard, in its space, and does a lot of things really well. And it begins to meet some of those challenges. Very strong from a scalability perspective, and perhaps best suited at very large scale. The ability to adopt commodity hardware with specific demands and needs, but still to move away from these custom built appliances onto standard HPE or Dell or Supermicro or Cisco or whomever. And fundamentally quite really software defined, so that as we architect for these requirements, we do that in a way that's really customizable for us, tunable for a bunch of workloads, very tweakable, so that as we look at some of these big data lakes or these large archive footprints, we can really custom tune these configurations to what we need. It's been fantastic for that. Part of why it's out there in the enterprise, though, is that it's what's been available. For companies that have adopted this approach and attempted to do what Google has done or Facebook has done and build their own frameworks, it's been one of the only options available. Open source based, limited tie-in to specific vendors, but really out there and well regarded in some ways, and with at least meeting the promise of some of these cloud needs. The challenge with it, though, is that in some ways, while it's allowed us to go build these software-defined storage networks based on commodity hardware, it has some real challenges in certain areas. Great at very large scale, but when you start bringing that down into the standard enterprise, if you will, or the smaller footprints, really not viable to do that at a small scale, where the operational costs and the local intelligence required to go craft this custom environment begins to outweigh operationally and from a capital expense the benefits that you get from something like Ceph, with hardware demands that are pretty significant that prevent us from being able to really reduce TCO. And while it's software defined, it is a loose affiliation of tool sets and not as carefully curated in some ways as you might want, some of the closed source traditional products have been. Also, as part of that framework, because it is software defined and because it is open source, it's incredibly difficult to dial in and tune and tweak for a broad range of workloads. So some of the difficulty of the traditional storage silos still remains from a complication perspective, from an ability to go drive a lot of different pieces from the same footprint. And certainly you have some enterprises that are anxious about the open source aspect of it. And then lastly, and I think that this is the most important piece, the level of complication, the level of intelligence involved. It's been argued that if you buy Ceph, you either need to buy a couple of PhDs or some very expensive support contracts. The ability of this framework to handle underlying hardware transitions, to handle evolving workloads, the complexity is simply too great to make it a simple, viable approach for the standard enterprise, even though it's been functional and doing well at large scale in some of the largest enterprises. But the last piece is that it really does fail to deliver on that data center that's been so beneficial for the larger cloud giants. Even some of the technical leadership, and I saw this recently in a web video, when asked about the ability to span Ceph across multiple sites and really present global namespaces, his words, not mine, that stretch is sketchy. It can be very powerful in a single site environment. It can be very powerful in a not too changeable dual data center structure, but really not built to present these kind of global data centers that guys like Google and Amazon are taking advantage of. And that's significantly limiting. So how do we do that? How does one do that? Those core requirements that are delivered on by someone working at Google and that we're working here at Hedvig, obviously, to go do, is to provide, with off-the-shelf x86 physically on-prem, but also in the cloud, whether it's EC2, Google, Azure Compute, weave those standardized servers together with software into a distributed storage platform, much like Ceph would, actually. But in our case, truly distributed and simplified, extremely elastic to scale up and down again and up and down again from as few as 3 nodes, very small scale potential initial footprint, to thousands of nodes and petabytes of data. To simply handle a unified approach for iSCSI, NFS, and object storage in a single platform, one that's able to handle heterogeneous workloads and that doesn't mandate specific tuning for specific workloads the way Ceph might. And lastly, that ability to support any hardware piece, any public cloud, any hypervisor on the client side, or any container framework on the client side, derives a lot of power and helps us achieve what Google has really done, which is to develop an internal universal data plane that works for all of their assets. And that's really what the baseline capabilities are for delivering against the kind of success that you see at Google and Facebook and Amazon. Absolute bulletproof resiliency, not within the single site, although that too, but across multiple sites and multiple clouds as well. The ability to automate and orchestrate, not just in the provisioning world, which a lot of traditional and new storage companies get to, but the instantiation and the deployment itself of these frameworks, so that you can move from ILO and network card up into full-blown private clouds without human intervention. The ability to scale out both across different sites and within the same site to as many servers as makes sense for your specific use case. And then lastly, the ability to apply all of that with application-specific, data-specific policies. None of this works if all of the characteristics and policies are driven solely through an array-wide perspective. It must be driven by policy. So with that as a baseline, with that as a kind of a fundamental underpinning layer, how do we get to where people have seen some success around this? And it's in a wide range of spaces. In the backup and archive space, relatively straightforward, and in some ways this is where Ceph has been most successful, in these very large archive footprints with single dedicated workloads without some of the, I'll say, high performance requirements of really production spaces. But we can take this type of hardware agnostic commodity footprint with software definition, span this data with really good data reduction across multiple sites and facilities, and potentially across the cloud, in a way to go offer people radical cost reduction and real tier 0 availability models for their backup sets. And we see this in a few sites, customers like Ernst & Young, for example, where they've decided that a software-defined approach is appropriate because of the elasticity, because of the avoidance of forklift upgrades, and because of the native site-to-site replication capability that could sit behind Veeam and NetBackup in their case. But that software-defined approach for them is that first toehold into a modern storage framework that truly begins to allow them to exploit this multi-site global capability. And at Ernst & Young, they're deploying single storage fabrics that are spanning multiple sites, typically two, typically a pair of data centers woven together, but often also pushing into the cloud. So very exciting use cases there. More importantly, in some ways, if we get beyond the Ernst & Youngs and the Scanias and states of North Carolina that are doing that in a somewhat tactical play that gives them that modern toehold, we begin to look at companies that are really leveraging some of these successes and beginning to adopt this global approach for core virtualization and microservices footprints. And this is an area where truly we've had a challenge as an industry, I think, in servicing what should be absolute commodity workloads and should be absolutely simple heterogeneous environments with a consolidated simple storage backend. So in a Ceph scenario, this becomes challenging because it does get tuned globally for specific use cases and may be perfectly appropriate for a specific OpenStack initiative or a specific OpenShift initiative, but not necessarily for also servicing VMware and Microsoft Hyper-V. Maybe not teased up enough to allow customers to push all of these across sites. And we see this in a couple of different scenarios at very small levels. And this is why we're not just talking about very large enterprises getting these benefits and trying to ask that what would Google do question, but outfits like Pittsburgh State University, where they've got 7,500 students, about 60 terabytes of deployed data now. It's grown a little bit, but with interest in pushing past that single data center as a limiter of their high availability. Really weary of the DR process. And this is in Southeast Kansas where they have a lot of storms and tornadoes, so a lot of heavy concern. They've adopted an approach where using software-defined storage frameworks with that true cloud era technology, they're able to weave together multiple data centers as a global namespace, address a single VMware cluster against that global namespace, and operate across 3 data centers seamlessly without regard to downtime at any given data center, certainly without regard to downtime on any individual node or any individual disk. So really powerful, simple approach that suddenly puts a small, 7,500 person university into the same level of resiliency and the same level of operational flexibility that's being delivered by Google today internally, that's being delivered by Facebook today internally. So even at a small scale, these possibilities apply. As we begin to scale that up, away from a single client model, doing this all for VMware or just for Kubernetes or just for OpenStack is well and good, but to be able to extend that out further into a scenario where customers need not only that improved availability model, whether it's across racks or across nodes or across data centers, but that phenomenal elasticity and at a scale where they can deliver their own private cloud frameworks to be as seamless as Amazon, to be as resilient as Amazon, and to be as, I'll say, far more flexible in some ways. Because, I'll pick on General Motors, who's probably not on the call. If I'm a General Motors, I'm not relying only on containers and I'm not relying only on VMware. I've got a broad range of things to do. And that level of heterogeneous approach is really powerful. So if we look at what Airbus is doing, really phenomenal piece of the puzzle where they're standing up underlying storage clusters from ILO and from network boot, fully automating the instantiation or the deployment of those clusters, doing the same level of automation, bringing Hyper-V virtualization frameworks, Azure Stack, Zen Server, OpenStack, and OpenShift into existence simultaneously. And then again, without human intervention and fully automated, bringing those together to form a single consistent cloud for their internal customer base. In this case, for departments of defense in the UK and Spain and Germany and France. Really powerful framework to deliver robust cloud scale capability without the level of manual effort involved with doing traditional arrays, without limiting down to individual tech stacks. And here we've got a software-defined storage layer as an underlying unifying tier, weaving together NFS for Zen Server, iSCSI for virtualization on Hyper-V, and object storage for many of the other elements, all as a single fundamental storage platform. And that is difficult to achieve. Really powerful, but really approachable, and clearly the kind of demand that we see from a lot of the large-scale enterprises. So if we take that one step further and begin to ask that fundamental question that says, we know that folks are operating at a global scale. We know that they are operating with an availability model which is pushed far beyond disaster recovery. How do we get there? And how do we take all of these different capabilities together and weave them into this true virtual data center that I can operationalize and rationalize, discarding technical debt? IAG has this problem, has had this problem. 6 or 7 airlines, a simple conglomerate built up over time, 25 data centers, 6 or 7 sources of truth with legacy systems and technical debt coming from Aer Lingus and from Iberia and from British Airways and several others. Their challenge is to understand and figure out a way to bring all of that together in a single rational source of truth that can simplify management and improve customer service across all of those airlines, and eliminate a lot of the downtime they've had over the last several years, which is a result of that technical debt. For them, that core cloud need of that underlying storage, software-defined storage system, was the ability to source data across physical sites, across Azure regions, across AWS regions throughout Europe, weave those together as a single operational component, single global namespace, defined by policy for whatever need or whatever purpose. In their case here, they're using OpenShift to rationalize all of those components that can be brought into that modern container framework, that microservices framework. Those that can't will be rationalized into a more traditional virtualization tool, OpenStack. But critical, both of these give them the ability to bounce and move workloads across Azure, AWS, and on-prem systems seamlessly. But to do that, you've got to have a storage layer that presents consistent global data on a volume by volume basis by policy, so that you can take a given container and say, this container based on GDPR must live only in the UK. So we'll use region 7 from AWS and region 3 from Azure and region 4 from an on-prem site, weave those together as a single strongly consistent storage namespace, and provide that for this set of VMs and this set of containers that must stay local to the UK. Maybe there are latency concerns and a certain set of data must live only on-prem in Manchester and London, and I'll make up a third site, Edinburgh, where the on-site piece is relevant, the latency issues are relevant, so that by policy we take a certain set of OpenStack VMs and a certain set of containers and force them into that namespace, or force a set of containers into a single namespace where latency is really critical, so that we know we can't survive the kind of round trip time we need to do this truly global approach. So that policy-based set of mechanisms, that policy-based approach to this kind of footprint is absolutely critical. And the ability to distribute for a range of use cases, simple integration, seamless and visible storage that natively carries data out across regions is extremely powerful. And that type of, I'll say, full-scale transformation is how we get to the successes that Amazon has and that Google has and that Apple has. So really powerful components. And those types of elements are what you need to look for. As you're choosing your own systems, you're going to have operations where Ceph or Scale.io or Nutanix or SimpliVity may be the right tool for you. And you're going to have other scenarios perhaps where you have the drive or the ability to operationalize and to push for the kind of efficiency that's being garnered by the cloud giants today. That's what these types of tool sets do. And I'll stop there in terms of the customer elements. And just as a refresh, that embrace of the global virtual data center is really the big distinction. There are a lot of small things that we do differently and that other shops do differently than sort of the more traditional Cephs and certainly the more traditional arrays. But those are the concerns and the questions that you begin to ask. Do I need to be protocol agnostic? Do I have to be concerned about data locality? How am I handling multi-cloud approaches? Am I in need of an HA strategy rather than a DR strategy? Those elements are critical. And I'll stop there and say, how do you go do that? Well, I think from our perspective is you work with people who've done it before. So Hedvig itself, born in the cloud era, the same time I'm with YouTube being told, no, YouTube can do it better by itself without buying from Pillar Data. You've got a young Avinash Lakshman beginning his career at Amazon, where he's co-inventing and developing key value store databases that live and reside underneath the Amazon shopping cart and provide the kind of elasticity and scale, the kind of availability model, the kind of global reach, and frankly, very low cost capability that drives the cloud giants today. After about 3.5 to 4 years shifting to Facebook, where he's the primary inventor of Cassandra, again, the underpinning for Facebook Messenger and what's become the world's standard NoSQL framework. Really powerful roots from that of driving a company whose job is to take those same techniques, those same efficiencies and capabilities and drive them into the standard enterprise in a universal storage platform that's really consumable. And that's what Hedvig does for a range of customers. And we went over some of those today. And obviously there's a greater number out there, but it's where we see our mission, and it's where we've seen a tremendous amount of success and where we hope to continue to help other companies going forward. So I'll stop there. I'm about 5 minutes over. I apologize, Angela. Do we have any questions out there on the line? I'm in presentation mode, so I don't have my my look at the chat window up.
Yes, actually, we do have a few questions. First off, yes, we will send out this presentation. It was recorded, so we'll send this out afterwards. Another question was, what is the maximum latency you can support between sites?
Oh, that's a fantastic question. And I'm a technologist, so I'll give you the standard answer of it depends. We're designed to withstand very high latency, and I've had customers I have customers today shifting data from New York to LA, from New Jersey to Dallas, for example. Even in the IAG example, we're spanning across multiple regions within Europe. But not every application can sustain those latencies with us. So we have certainly techniques where we can deploy in a widespread way, but minimize the latency impact. And in some scenarios, you'll be controlling the size and scope of your fabrics based on those latency concerns. Maybe we can only carry this data across town. Maybe we need to stay local within a campus, but span that data across multiple rooms or across multiple racks in a data center because the latency need only allows that. But we can fine tune that based on the application use case and on the assets of the customer.
Fantastic. I think this one's taking a little dig at my marketing slides. Just kidding. But it says, showing a global map is very pretty, but how many sites can you really support in a single system?
That's a great question. I can't say infinite because we don't have an infinite number of data centers out there. It's most common to take individual bits or individual data components and span them across 3 data centers. If you do more than that, which we certainly support, we do up to 6 for individual blocks today, it becomes a little bit wasteful. I could see people doing 5 or 3 data centers for specific volumes, but the broader cluster size is really indeterminate. We have, IAG, the final design for that is 9 data centers. They won't span data across all 9 of those sites. They'll pick and choose by policy where that data needs to live. And, it's really a question that depends on the type of assets that a given customer or a given enterprise has available. If you've got 5, data centers spread across a metro area, maybe because you've got 5 hospitals, it would be perfectly appropriate to weave all 5 of those together as a single operational space. So we might look at how to regionalize that for a given customer or how widespread that needs to be. But 9 is the most we've done so far.
Okay, just time for a couple more here. All of your customer examples involve multiple data centers. How do you help a customer that only has 1 data center?
Oh, that's a great question as well. We look at multiple site scenarios a lot because, frankly, no one else is doing that effectively, and I should say no one but Google and Facebook and Amazon and the cloud era giants. But so it becomes a big part of our value prop, and some of our core customer use cases involve that. But we do deploy at single sites on a routine basis, sometimes with people really valuing the automation capability, the software-defined aspects, or our heterogeneous capability to source a lot of workloads. Airbus, for example, while they have 9 different data centers, their individual workloads are not spanning across data centers. They're spanning across rows within a data center to give them better availability than a standard array, but that's teed up within a single site, each of those core data sets. So we handle that quite well. I think the only other thing I would say is that when you can adopt a multi-site approach, 3 data centers across town, for example, there's room for some incredible financial efficiency there because all of those are bonded together and woven together to handle HA across that regional network. And that's actually where you see the tremendous cost savings for someone like an Amazon or a Google and Gmail, for example. They're not keeping a bunch of RAID and a bunch of multiple copies at individual locations. They're leveraging those data centers together to deliver that capability.
Okay, and we'll take one more question here. Todd asks, can you speak to your competition and why your product set is a better investment?
It's a great question, and thank you, Todd, for bringing that up. I think and I'll answer it this way, we actually have a lot of different competitors depending on what people are trying to do. So, we talked about a couple of backup deals today, and we've got companies like Rubrik or Cohesity that are trying to be the full backup stack. Companies like Data Domain that are more long-standing. In the container namespace, we've got customers with traditional arrays like NetApp, of course, or tools like Portworx, etc. I think generally speaking, our biggest differentiation there, even if we get away from the automation and get away from how elegant and simple our software-defined framework is, it really comes down to either the geographic distribution and our ability to craft these global data centers, which is extremely powerful, no matter what the use case is. Letting go of disaster recovery and building toward an HA model instead is a fundamental expectation that's there today. And there are very few companies that can deliver that in more than a
Christopher, I think we lost you here. Your audio is not coming through. But we can certainly finish this via email when we send you guys the presentations. We can also talk a little bit to what that question is, right? The competition and where we're a better investment.
Hyper-V together, it gets difficult. Yeah.
So there you are, Christopher. Okay, we lost you for a minute.
Oh, so sorry. Yep.
That's okay. So anyway, that wraps it up for us. Thank you so much. We appreciate your time, and we hope to speak with you all again soon. Thanks.
Thank you, and take care, everyone.